Can you all hear me? Okay. So, hello everyone. First of all, thank you all for being here and made it to the Friday and decided to come to this talk. I'm Luis Rilo. I'm a consultant manager at ForgeFlow, and today I'm going to speak in this talk about supply chain and how to improve it and put it to the next level with these sequential processes. We see the agenda here. In the right-hand side, you have the Q&A pad link if you want to scan it. And I will jump right into the introduction. So as I said, the idea is to give some best practices to improve your supply chain, get a better return on your investment, and we are focused in connecting the customer demand with the supply, which is something that intuitively we know that can be done, but it's not an easy at all task. We will split this into three processes, sequential processes. The first one will be demand planning. We'll discuss some key best practices about forecasting your demand. Then stock planning will quickly go, so on the calculation or our flavor of defining the stock levels. And finally, in supply planning, we'll discuss the generation of new orders and that projected into the future to have a plan. Let's dive into demand planning now, and the first question that we have is how much demand can we expect in the next period? Obviously, the answer to this one is really relevant because we need to start it right, otherwise we will be affecting the next steps. We define some key steps that you see here in this process. The first of it is setting an appropriate objective. It's very important to use good data, have good data quality. Then we need to monitor the result of our forecast with relevant metrics and deciding what metric to use, because there are a lot of them. Generating the forecast baseline means that we start by generating with our forecast model first forecast that is done by the computer. I won't be digging into this too much because I don't want to make it too technical and I don't have time. But whatever your forecasting model is, being it machine learning or a statistical model, you will need to review it after having it. And in the last step, you need to focus in efficiently do that and adding value while reviewing. When defining the objective, we need to ask ourselves some key questions, and the ability to answer them will define a lot of things. I have here some examples. What do you need to forecast? Why do you need to do so? What decisions are going to be made using that forecast? Who will take those decisions or who will use it? Some examples. Deciding what to ship to local stores weekly. Obviously, this is something that is very detailed. It will be done at SKU level and by store, so the aggregation level is very detailed. Weekly, very small buckets, and as it's something that is short-term, you don't probably want to spend too much time reviewing this, so you don't want to lose time, and you need to involve few people, probably demand planners. In the second case, creating the MPS for your manufacturing plan in the coming months is more tactical. In this case, maybe you will use months or something bigger. You will do it at SKU level. Maybe if you have several plants, you also include the plant as one aggregation level. But at the end, in this process, you will involve more people. You will have probably and configure a sales and operations planning team that includes people from sales, marketing, obviously planning, etc. And the last one, setting the budget for the next year. This is very aggregated, so it's probably you will do it by quarter and by product family, collection, etc. And it will be meant for decision makers, strategic decision makers in the company. So we have to have all this clear before starting. Also, one important consideration is to define the appropriate forecasting period. So how long should I focus when reviewing my forecast? I have here a quick example that is the basic one. So we have a main supplier to whom we order every first day of the month. So the day 1 of each month we can order. And we have with him agreed in a 2-month lead time. You may think that considering this, the next 2 months will be enough, but you need to also consider this review period, because imagine you are in the day 5 of the month. You cannot do any action until the next month, until the next first day to trigger a new order. So our risk period is what we need to focus on, at least, and in this case will be 3 months. It's also important to decide what we are forecasting. So we are focusing on demand forecast, specifically on constrained demand forecast, and this is what the customer really want when they want it, and in the quantity they want it. This is very challenging. Obviously, we can have problems with the inventory availability and supply availability that can lead to shortages. Demand collection is not really easy, because this is not sales, this is not deliveries, obviously this is not invoices. Also the bullwhip effect, if you are a manufacturing firm, can be a problem. As you are upstream in the supply chain, you get more consolidated demand in buckets, and it's a bit a distortion. And it's, at the end of the day, it's almost impossible to have the exact demand measured, but we can at least give some advice. It's really important to have an efficient order collection and management. We need to distinguish, apart from open orders, we need to distinguish what are duplicates, to not count twice, cancelled orders, to ignore them, substitution orders, because they are using a different product for any of the reasons that, for example, we see below, and we need to consider that. We need to manage uncollected orders. In periods of shortage, we have demand. It's just that we cannot deliver it. In that case, we will not register sale orders, most likely, so it's interesting that you provide this information to your forecasting model to be able to censor those periods and not distort the result. You can also consider to use in some models different demand drivers, like visits to your commerce site, the introduce data of new product introduction, and you can think of it. It can be, for example, the temperature if you sell ice cream, to put some example. This can be a lot of demand drivers that can influence. Beware of course of substitution and cannibalization. When you add some promotion to some product, you might be affecting some other. That's cannibalization, and you need to consider it. And also, this is important for any process, but it's important here also to collaborate with your partners, in this case with your clients and your sellers, to try to get the data the closest to the final consumption point. In metrics, this is a bit technical topic, but what we can discuss here, I don't want to show any formula, is that they are important to have an objective measurement of how we are forecasting. There are a lot of metrics out there. It's not an easy task to choose any of them, between any of them, but we need to choose one that does not generate bias or inaccuracy or make us focus on the low impact streams. Long story short, for me, in most of the cases, mean absolute error and a bias used combined both as percentage, it's a good metric, and you can start by using that. Then, okay, we have our metric set. We know how to compute the error of our forecast. But what is good? What is bad? Do I need to have a 1% error? maybe that's not worth it. So to set the goal, it's very important, first of all, to compare apple to apples. So you need to compare, if you are forecasting demand, don't go then and compute against sales orders. You need to again compare against real demand in that period, considering all the things that I mentioned before. With this, we can compute the error, and the idea is to define a benchmark. So a very simple forecast model, I propose here to use a moving average, typically with 3 periods, 6 periods in the past, is fair rival. It's not that easy to beat as you may think, and that can set you an initial goal. Industry benchmarks, there are up there some benchmarks, but it's not a good idea. At the end, you are not comparing apple to apples, as I was saying, so they may have a very different catalog, they may use different metrics, you don't know how they compute it, you don't know if they massage the numbers, so they are usually not good. When you review a forecast, and as you add stages to that review, you may involve different teams. It's very important to focus your work. One tip that I can give is to use value-weighted KPIs. So you have your error and your accuracy in a metric, but you can multiply that by the value of the product, by the margin, and that will give you the idea of what can have the more impact and focus on those ones to really add some value. ABC, SYC segmentation or a multidimensional one can also help to know what's the priority when doing the review. And then always leave what's not important and not relevant to the forecasting model. You may have a huge catalog and it's physically impossible to review everything. Also, as I said, you may involve different teams, and a framework like the forecast value added can be good to measure objectively the efficiency of each of the steps. You can, with this, say objectively someone or some team is adding more accuracy to the forecast or not. Alright, so we have our forecast done. Now it's time to inventory planning. In this part, we are going to define the stock levels, especially based on our forecast, to be able to have a good service level towards our customers. I don't have time to show formulas, etc. So typical factors that are considered in this step to set this stock level that is ideal for each SKU. Forecast result, we have been discussing that, so that's obvious. Then lead time is very important. You need to consider some factor related to variability and consider the greatest from demand or supply, because you know you can have variability from both sides of the supply chain. You can include some influence by the product importance, by the forecastability, and in some cases, if a product is important in your business, you can give it priority and have more safety stock for that. So have a higher stock level to better protect your important product. So we need to find this optimal, and I like to say that it's a range. There is no magic number. I need to have 132 units of this product. There is actually a range. You have an optimal range in which you are far from the too little and the too much. You are just in the middle, and in that case, you don't experience the problems that you have here, like missing sales, paying expedite shortages when you have too little, and in the too much, making this inventory a liability because you have excess of cash capacity and space committed in this inventory. At ForceFlow, we like to address this with DDMRP stock buffers. I don't want to go too deep into this, but what I can show you is that the main idea of this, you can see it as super reordering rules with a lot of more features. They have a main sizing factor that is the average daily usage, so the daily consumption that is estimated for that product, and that is based on the forecast. And then with this and some other factors, you will translate the forecast that is actually a range. You have a confidence in the forecast that you are between a range, between the optimal and the pessimistic. And you translate that in another range, which is the buffer. And that buffer also fluctuates in the time using that forecast values automatically. So your system is automatically adapting to what you forecasted. As I said, I don't want to extend too much on this, but I can list some benefits of stock buffers. They can give priority, as you saw these traffic light colors in the buffer. They give priority for the order generation, so you need to focus first on the red ones. And they also give priority for execution of open orders in a manufacturing plant or even for purchasing. They ease the collaboration towards a common goal. If you give visibility of these metrics and these buffers in the appropriate points, all the people in the organization works toward a common goal. And that's better than have different KPIs for everyone. They react to real sale orders because they use a special lever to define the level of the buffer, that is the net flow position. They work in ranges, as I mentioned. They dynamically adjust, and they include a lot of tools to put in place a continuous improvement loop to not only set the level, let it work, so that you have retrospective view at the past and keep improving and having more and more efficient stock levels. Okay, so we reach supply planning. At this point, we have the demand forecast, we have our ideal inventory levels, we have our buffers, the size, the different colors. Now we need to coordinate that to answer these questions: how much do I need to order and when do I need to order? Here I failed myself. I have a formula in the slides, but I could not avoid this one. It's assume the net flow equation. This is what tells what's the level in a DDMRP buffer. And it considers on hand, supply order, that's normal, it's a reordering rule, use that, but it also includes qualified sales orders, demand, so orders that are above what's normal, so spikes, and you can anticipate to that, and today, what is due today. This helps a lot to handle abnormal events. So, and then when you go below, this lever goes below the green zone, you enter the yellow and the red zone with more priority. In any of the cases, you need to reorder and to move this lever again to the top of green. So that gives you the quantity, and the when is today plus the lead time. Simplifying. Okay, that's fine. We know what to order and when now, but I also need to plan the future. So it's good to have a plan for the future. And it's important to plan strategic decisions like capacity, space, cash needs. So you need to anticipate that. Also, and here again, I mentioned collaboration. So it's important also to give visibility to your suppliers. If you give this supply plan to your suppliers, you are enabling them to be a better supply, and this ultimately benefits you because they can have a better forecast because you give them more information, as I mentioned in the beginning, and this can reduce the variability that you get from that supplier. So it's not it's always important to do this. How to obtain? Simply project your stock buffers into the future. This is more or less how a stock buffer in an ideal world, all perfect, all as designed, no changes in size work. We have the net flow position, the flat line that fluctuates in the green zone. As soon as we reach the yellow zone, perfect timing, we trigger a new order, we consume, we trigger a new order, so this generates new supply orders, and at the same time we can have the visibility of the stock on hand which is the dashed, the dotted line. Some extra supply planning considerations is that we need to be careful when defining the horizon and our horizon of interest, because if we want to have a plan, let's say 6 months into the future, we will need at least a demand plan of 6 months into the future, and actually more, to be able to forecast the last periods. And one final comment: contrary to a forecast, we can fix some of the planned supply order in the plan and let the system project without touching them. So work around them and see the effect of that. So we can have a freeze period, maybe let's say 3 months, but then you even have a longer planning that is more dynamic from the 3 months and on. All right, so if I have time, I would like to do a very small overview of our system and how we implement that. We have a forecasting application in which I will create a quick forecast. In here, you can add the description, then you select the profile. I have a couple of them here, simply configured as an example. Let's choose this one. The profile is your forecasting model. Here you can use where you want, and inside you have the different parameters that are more technical, but is what define how it will be computed. Then I will forecast product A in this case, and then the input data we can define. In this case, I will use an Excel file because this is a demo database, but you can take the data directly from an Odoo model, stock moves, sale orders, etc. You can use a specific SQL sentence if that's helpful, or use other kind of files. In this case, I have here some Excel file. Then you decide the period that you are interested in, the aggregating period that you want. Let's say monthly, start of the month, and I'm interested in having 8 months of forecast. All right, let's save and compute. Okay. So in this case, what we see here, the dots are the past demand. So it's actual demand in the past, and it's our input is what was in my file. It was some random numbers that I generated. And here we see this blue line that is what the forecast model generated, is the projection. And I don't know if it's very visible in that screen, but this shadow is the confidence on that. It's not a precise number, it's a range, as I mentioned before. Okay, and the result of this, we can see here, is demand estimates. We call it like this, is the need of stock for that product in our warehouses. So we have our forecast, and then in the inventory, here I have under products the stock buffers. I have here the product A, and we have the information of the stock buffer. We have the ADU, average daily usage, that I mentioned. Here we have magnifying glass where we can see the stock demand estimates that are affecting now this computation, the next 2 months in this case. We can see some more details on how this is computed, the chart of the buffer, some more information about the different values here, always with details, some demands about supply, demand, etc. I don't have time to enter in detail now. And here in the last tab here, we have the projection into the future, what we call an auto simulation, but it's a projection into the future that will have this shape. So the system, using the data that we entered as demand, projected this, and this generated the supply plan that we have here. The supply plan already includes some confirmed purchase orders, but as you can see, there are a bunch of them that are just simulated. So it's the projection, and this is what we can share with our suppliers. You can also have here a visibility. Well, I don't have much data here, but of more products you can aggregate and all the products of a supplier, group it here, and send the full overview. All right. So this is what I wanted to show today. Here you have again the pad link, the QR code, in case we have time for some questions. You have my contact, and you can also check forceflow.com/event to see the trainings that we have planned. We have one in November if you're interested on DDMRP.
Okay. First of all, thank you so much for your presentation, Lois. There are some questions in the pad. The first 1 minute is quite a long question. If the person that did it wants to explain later, please feel free. It says, will the demand planning suggest you automatically the optimal order quantity for a specific item based on the parameters like selling frequency, product availability, and your preferred stockage time and expiration date range for food products? If not, which other parameters can you already set at front for each item product?
Okay, yeah, that's a long question. We can discuss in detail, but what I can say is that once you enter the forecast, that is part of one of the factors that affect the stock buffer. But there are some others that you maybe quickly saw that you can tweak to affect the size and the recommendation, because the final recommendation of the quantity to order comes from the buffer and the sizes of the zones. So you can include any other factors. So we have some by default formulas, but we commonly find that we adapt for the specific use case. The important here is that the buffer, some of the buffer has a purpose, and that you respect that. You can introduce more complexity in the formulas if needed.
Is that enough of an answer? Does the person who did the question would like to come up with something else after that answer? No? All right. We also have another question. For the supply plan to work, is the main precondition you need good collaboration with your supply plan, or otherwise?
Can I read it?
I think.
It's writing maybe. Huh?
Yeah. Okay. We'll let that one be finished. What is the most advantageous compared to MPS?
So MPS is typical MPS is used when you have a traditional MRP. The thing is that when you use an MPS, you are planning precise numbers, and the problem with precise numbers is that they start outgrown. You will never nail it. And they typically, especially in manufacturing plants, they will generate like a distortion in your stock, that you tend to have a lot of items that are stocked because you have remains, and some items that you have too few, so it ultimately generates like this separation. You don't have the distribution that you want in the optimal range. And well, this is a long explanation, but in DDMRP this is solved by decoupling a bit this plan. Also helps reducing the planning horizon needed, and at the end, as I insist a lot on that, you are planning capacity ranges, and if the stock is finally not needed, in the MPS you say, I will build 1,000. If you finally have zero demand, you will build the 9,000. With a buffer you define a range, so a capacity range. So I plan to have this amount of stock, but if then the stock is not needed, no new orders will be generated. So you will not produce more if you have zero consumption.
Thank you very much. We do not have time for more questions, I'm very sorry, but you have been told by many. Thank you, Lois, great conference, very useful, and feel free to approach him because there are a lot of questions, interesting questions that you might get asked later. Thanks a lot for your presentation.
Thank you. I will be at the booth for some minutes after that, so you can come here. Thank you.